Hey guys, welcome back. In the last lesson, we saw how to create a database and a table in Hive. In this lesson, we will look at the details behind the Hive table. More importantly, we'll see what are the essential elements that is needed behind a Hive table. We've already created this database stocks_db in our last lesson, so we won't do it again. Show databases will list all the available databases in Hive. So let's execute that. There you go. Here you can see the database stocks_db. Next, we will execute use stocks_db to switch to the database stocks_db. Let's now create a table for the stocks dataset. Very simple syntax. The table name is stocks. We have listed all the columns in our stocks dataset. Our dataset is a comma delimited dataset, so that is why in the create table instruction we will say row format delimited fields terminated by comma. So let's create this table. The table is now created. The describe formatted command will show you the detailed information about the stocks table. This information is very useful, especially if the table is not created by you, but you want to know more information about the table. So let's try that describe command on our newly created table. First, you'll see information about the columns in the table and its data types. The data types you see here are very similar to Java data types. And next, you will see information about the database that the table belongs to, created timestamp, etc. Now let's look at two important attributes of the table. The first one is the location and the second one is the table type. The location attribute specifies the HDFS location from where the table will look up the data set. In fact, when you create a table, you can specify the location attribute if the data set already exists in your Hadoop cluster. So what happens when you don't specify the location attribute? By default, whenever you create a database, Hive creates a directory in HDFS. And whenever you create a table, by default, Hive creates a directory for that table under the database directory in HDFS. So for our stocks_db database, Hive has created a directory in HDFS named stocks_db.db. And for the table stocks, Hive has created a directory in HDFS named stocks under the stocks_db.db directory in HDFS. Both these directories are created under user Hive warehouse directory. It is also simply referred to as Hive warehouse directory. Next important attribute is the table type. There are two types of tables in Hive. The first type is called managed table and the second type is called external table. We are going to look at table types in detail in a separate lesson. So let's move on to the next set of attributes under storage information. These attributes will tell us about the format of the dataset and how the data is read and written during Hive execution. When you don't specify a table format when creating a table, Hive will make text input format to be the default input format. And Hive ignore key text output format as the default output format. Hive ignore text output format is very similar to the text output format. The only difference is the value of the key is ignored in the output. But what is SERDE? It is pronounced SERDE, and how SERDE is different from the input and output format. Every time we ask this question in an interview, we get very poor answers. So I have a couple of slides to show exactly how SERDE fits in. SERDE stands for serializer and deserializer. When you read the data, deserializer from SERDE is involved. And when you write the data, serializer from SERDE is involved. Let's say you want to find the maximum volume for stock symbol like GE, for instance, from your stocks table. You will write a query, select max volume from stocks where symbol equals GE. At runtime, Hive should be able to parse the record, find the column value that corresponds to volume, and map the value to the volume column in the table. So let's break it down even further. Hive knows your dataset is a text file, since the input format is text input format. So the record reader implementation in the input format will return you line by line as records from the dataset. Once Hive has a record, which is nothing but a line of text, the deserialize method in SERDE deserializes the record as a whole. Now the entire record is deserialized, and now we need some help to get the needed data from the record. In our case, we just need the volume column. Mapping the deserialized record into columns is done by a class called Object Inspector in SERDI. The Object Inspector knows how to construct individual fields. Again, in our use case, the Object Inspector will know how to extract the column value out of a deserialized record. The exact reverse happens during a write operation. That is, when you're trying to insert something into a table. Serialized method from SERDI will be given a deserialized object representing a record. The serialized method will make use of the Object Inspector to get the individual fields in the record and convert the record to the appropriate type, mapping back to the table. The output format then writes the record into HDFS. That is how SERDI input and output format work together. Let's go back to the details of the table. SERDI is simply a Java class. When you don't specify a SERDI, the default SERDI is lazy simple SERDI. You can also write custom SERDI as well. SERDIs can be very powerful, and you will see that when we work with Twitter dataset later in this chapter. You see, Twitter data has several columns and is represented in JSON format. And the data types of each column is not necessarily a simple type like string or float, meaning most of the columns are complex types like structures, arrays, and they are nested. In such instance, SERDI helps in two ways. One, to interpret complex and nested data and map it back to our columns in the table. And second, to map just the needed columns instead of mapping all the columns from the dataset. We'll see that in more detail when we talk about collection types in Hive. Okay, now we know about SERDI. We've also created a table and know the details and the meaning of important attributes of the table. But have you thought about what really happens when you create a table? Meaning we know where the data for the table is stored. It is stored in HDFS. But where does the metadata for the table is stored? That is, the information that you're looking at, where this information is stored. The metadata of the table, that is the information you see on screen, has to be persisted somewhere. So it can be looked up outside of this existing Hive session. When you create a Hive table, the metadata of the table is stored in a database like MySQL or Oracle, and it is called the metastore. Usually, MySQL is used in production setups. The metastore will only store the metadata information and not the data itself. The data itself will reside in HDFS. And this is a very important distinction to understand. But how does Hive know where the database in MySQL reside and how to connect to it? This information, along with several other key properties, are stored in hive-site.xml file. The location of the file would vary from cluster to cluster. In our cluster, hive-site.xml can be found under /etc/hive/conf directory. So let's look it up. We'll go to the directory etc hive-conf and open up hive-site.xml. Here is the contents of hive-site.xml. The very first property, that is the connection URL property, will list the URL for MySQL where the metastore database will be stored. This file also has information about the JDBC driver to be used and other connection properties like username and password to connect to the database. So now reading this file, Hive knows exactly how to connect to the metastore database, where the metadata, just the metadata for the Hive tables and databases are stored. Now we know how to create a table and where the metadata for the table reside. Let's finish this lesson by looking at few drop commands. You can drop the database with drop database command, and you can drop the table with drop table command. Pretty straightforward. But you can drop a database only when the database is empty. If the database already has tables, you will either have to drop the tables first before attempting to drop the database, or do a cascade drop with command drop database, the database name space cascade. That is it. When you execute this command, the database will be completely dropped. With that, we come to the end of this lesson. To summarize, we know how to create a Hive table. We understand the attributes and properties behind a Hive table. We know what is a SERDI and its purpose, and finally we looked at the metastore. Don't forget to ask questions if you're not clear with the concept. Practice what we saw today, and see you in the next lesson.